once again, Assalamualaikum warahmatullahi wabarakatuh. Good morning. Hope everyone is doing okay. We are already in week 5, I believe, right? Is it?
Yes, sir.
Yes, sir.
Yep. So, yep. So, several more weeks before we have the midterm. So hopefully everyone is on track with their studies for the first 4 chapter that we are covering until now, because normally in midterm we will cover from chapter 1 until chapter 4. That's the normal coverage of the midterm. um, so yeah, that's number one. Hopefully, because after we have covered chapter 4, we will continue on to cover the other chapter as well, according to the schedule. So meaning during the midterm we actually covering perhaps chapter 5. So you have to be able to, how to see, simultaneously covering, because those chapters are also important for the final exam, but at the same time you have to prepare for your midterm, right? So the best is when you are covering chapter 1 until 4 right now, make sure you already understand everything, so that is more just a revision, and you can keep track on both. Anyway, so that's number one. Number two, yeah, we will have a quiz at 9 a.m. this morning. It will cover both part that is in chapter 4, which is moment about a point and moment about an axis. Right. Okay. So the first 4 chapter is the fundamentals, basically that will be used for chapter 5, 6, 7, and 8. So make sure, because if you struggle with any of the chapter 1, well, not chapter 1, chapter 2, and 4, for example, um, to solve what we will be facing in chapter 5, 6, 7, 8, because it will require the fundamentals from chapter 2 and 4 mostly. So make sure you understand, um, and if you have any issues, any problem, anything not clear, please do ask. I'm hoping that everyone is okay, because most of the sessions, discuss session, not that many ask question. So perhaps, hopefully, to those who are in a discussion group, you manage to resolve it there. But because from the quizzes, it seems that some students still struggle with some certain things. So I'm wondering whether what's the what's the case, because in the class session, no one, or not that many that ask question. So I'm hoping that everything is okay. Right. Okay. What else? I don't have anything else to add this morning. Just to remind once again, please make sure you understand the concept as well as how to solve for every single component. Right. So in chapter 4 we have 2 components already, and we have several more to go. And make sure you understand what's the difference between, for example, moment about a point and moment about an axis, and how to deal with them both in 2D and in 3D, and especially in 3D because you will have to deal with vector operation, right? All right, so as usual, I'll be on standby for these 2 hours, inshallah. So proceed with your activities and preparation for the quiz, inshallah.
Okay, sir.
Okay, hopefully the slide is clear. Okay, so this is from the slide, the lecture slide, right? And you ask about this question for both of these. All right, so for number one, for finding the moment of the force F, so we have the force F here, about the x-axis, the position vector in the triple scalar product should be, all right. Where's my mouse here? Okay. Let's use. Okay, so first thing, when we say triple scalar product, we mean that when we say M equal to, because this is more than one about an axis, right? U dot R cross F. Okay, sorry with the writing because using the mouse here is not that convenient. Okay, so this is basically what triple scalar product is referring to, because we have 1, 2, 3 vector that produce a scalar over the left there, right? So this is the triple scalar product. So the question says to find, because this F is already given, so to find the moment about x-axis, what's the x-axis? So this is the x-axis, x-axis. Right, so to find the moment of this force about the x-axis, the position vector in the, so meaning that the position vector referring to, yes, we use this, referring to this R here, right? This is the position vector in the triple scalar product. So between these four options, A, B, C, D here, which one should be used for this R? And the important point to understand about this R is it is from the axis to the force, right? So this one you should understand the concept. So R in the equation is from the axis to the force. So any point from the axis here to the force here should be okay. So if you say, what about RAC? AC is from point A here to point C. That is not from the axis. It is from the axis, but it is not to the force, right? So if you use this one, it is going to be wrong. What about RBA? So from point B to point A, if you took this R, oops, it is from the force to the axis. So this is wrong. What about RAB? So it is from A, which is from the axis, to the point B, to the force. So the correct one is RAB. Right. So this one is also wrong because it is from the force to something here. Right. So that's the first question. The answer will be RAB. This is if the question asks exactly what the question asks, which is moment of force F about x-axis. So if the question is about y-axis or about different axis, then you have to check similarly, right? As long as it is from the axis to the force, it should be fine, meaning that any point will give the same answer. For example, if we have another point here, right? For example, if we have, maybe I should use a different color. So if, let's say, this is point D here, let's say, right? So can I use DB, meaning that RTB, oops, DB? Yes, you can, because it is still from the axis to the force, meaning that if you use RTB or RAB, you will get the same answer in the end. Right, okay, so that's the first question. Is that clear for the first question? Do you understand the concept and why the answer is as such? All right. So question number 2, R is given as 1I plus 2J meter and F equal to 10I plus 20J plus 30K Newton. Then the moment of F about y-axis is, all right, so this is basically just plug in into the matrix, right? So basically you have the matrix of, you have the unit vector on the top row, position vector in the middle, and force at the bottom here, right? So for the force, it's straightforward. That 10, 20, 30. And for the R is 1, 2, 0, right? 1, 2, 0. If R is 1 and F, then the moment of F about Y axis. So Y axis, you have to basically just input the unit vector for Y axis, right? So what unit vector for Y axis is unit vector, for Y axis is J, right? So 0, 1, 0 here. Right, so if you do this, if you calculate this one, you'll get 0, of course 0, and then minus 1, 30 minus 10. So minus 1, 30, so minus 30 plus 0, right? So it should be minus 30, right? That's just from the calculation of the matrix. So this one actually, it does involve a bit of calculation to get the answer. Yeah. So is that clear on the second question, or is there anything not clear at any part? All right. So,
Assalamualaikum, sir.
Waalaikumsalam.
Can you? I'm sorry, but I'm having a problem to understand about the unit vector. For example, in example 1, unit vector is I, but in group problem solving, it's J. The unit vector is the one that parallel, right? So for the group problem solving, I understand why the unit vector is J, but for the first example, I don't quite get it. Why it's in I?
Okay. Let me. This is based on the lecture slide, right?
Yes.
Example 1. Okay. You are referring to this one, right? Oops.
Yes.
Why is it blinking? All right. So okay. First and foremost, with regard to you're talking about the unit vector in the equation, right?
Yeah.
So when we are talking about unit vector, R cross F. Right. So first thing first, you know which meaning each of these three are referring to which one, right? Meaning that the force is clear cut, is the force.
Yes.
R is from axis to force, and the unit vector is for the axis. That one you clear, right? Alamak.
Yeah.
Okay, so when we're talking about the axis, meaning that the question will always have to specify if the question asks to calculate for a moment about an axis. So which axis are we talking about? So in this particular example, when you say the magnitude of the moment of this force about x-axis, so meaning that this is the axis that we are talking about, and this u have to reflect this x-axis, right? So unit vector, okay, if you have x-axis, kenapa dia macam gitu? So the unit vector for x-axis is I. The unit vector for y-axis is j. The unit vector for z-axis is k. Okay, so that's number one. When the question say what is the moment of any force about x-axis, obviously the unit vector is I. Is about y-axis is j. If it's about z-axis is k. It is if it's about any different axis, then most of the time we have to use the coordinate to find the position vector, and then magnitude, and then you can determine apa maksudnya gini, the unit vector, right? So that's basically about the unit vector. So okay, so which part? Okay, so for this question, can you understand why it becomes the unit vector is I? Because it simply say the moment is about x-axis.
Yes, sir. Yes, sir. Understand.
All right. So any further meaning for the other question as well? Do you understand? Meaning, for example.
Yes, I get it, sir. Thank
All
you,
right.
sir.
Okay, welcome.
Sir,
Yes.
I have a question regarding one of the tutorials for, I think it's says over here question number 3.
The tutorial.
Yeah, moment about a point and axis.
Okay, so what's the question?
So for question C, I watched the explanation on the video that you said that it doesn't matter from anywhere across line AB that the moment on what is that? The force is 0, right?
Come again, and it's not clear.
Sorry, from anywhere along the line from A to B, if there's what's that, from line connecting to C, the moment would be 0, right?
Wait, this is which question? The third question?
Yeah, it's just question 3, but inside the slide it's slide page 3. Yeah.
Page 3. This one with the wrench?
Oh no, it's the one with the, I think it's pipes.
Oh, okay. The third slide including the cover page. Okay.
Yeah.
Okay, so the last part, is it?
Yes, the last part. I don't quite understand why it's 0. Is it because it's a vector that's pointing through the point, or it's not like a fixed distance, or I don't quite understand.
Okay. You are, because there are two how to say, moment about line connecting A and C and also B and C, right? So which one?
Yeah.
So for both, if you are to calculate, how will you do it?
If we were to calculate, I would use the point coming from. Oh, it wouldn't. It would use the same, isn't it? Like you would just find the moment across the line, AB. So that means it will be the same value.
AB. What do you mean for AB?
Like if we were to use the formula for what is it called? The triple cross product, is it? What's it called again? The one with the unit vector and line vector and also the force. It wouldn't matter, right? If you were to choose from anywhere along the point for the unit, for the position vector.
For the position vector, okay, as long as it is from the axis to how to say, from the axis to the force, it doesn't matter. Yeah. Let me see. Okay. Is this question right?
Yes, this question.
All right. So there's two, and we're talking about this part C, right?
Yes, only part C.
Okay. So there are two moments there, right? To compare. One is force about line that connecting A and C, meaning that this line here, this axis here, right? Lama.
Yes.
Basically, okay, this one here, right? And the other one is connecting B and C, which is this one, right? So there's two different lines. So meaning that if we compare moment of this force about this line and about this line, which one is larger? Basically, that is what stated in the question, right?
Yes.
Now, if we, okay, let's change the color, right? So if we are talking about, okay, so in terms of the triple scalar product, so basically we have M, go to the vector, dot, yeah, of course this is not exact. Right, so I'm just writing them, but of course, this will be in vector, vector, and vector, right? So the unit vector is for the axis, right?
Yeah.
So that's number one. But the important thing here is with regard to this position vector. Now, when we say it doesn't matter, meaning that from any point of the axis to any point of the force. But of course, for the force here, we only have this point here, point C, right?
Mhm.
Of course, we can use this one as well, but that's the point there. On the axis, you have 2 points. For the purple one, you have two options, right? One is to use point A, and the other is to use point C. If that one, do you understand or not?
Sorry, come again?
Okay, if we have, because in terms of the concept, you understand, right? Meaning that R is from the axis to the force, right?
Yes.
So if we have an axis and we have a force here, so if I use from this point to here as my R, or from this point to here as my R, both will give you the same answer.
Oh, yes. Uh-huh.
Right. So in the purple line here, the axis have 2 points that we know of. There is one point A, one of point C.
Uh-huh.
Right. So if the easiest one is to consider from point C, right? So if R is from point C, which is the point on the axis, to point C, which is the point of the force, the R is 0 actually. Faham ke?
Sorry, 1 second. Trying to compute it. So
Because, okay,
basically, from A to
because
C, there is a distance, but from C to itself, there's no distance.
okay, let's say, because if okay, yang on the right here, if this is point A, right,
Okay.
and let's say this is point B, this is point C, right, let's say. So for R, I can use RAC, this one, or RBC, right?
Uh-huh.
Meaning that I can use RAC or RBC. Both will give me the same answer. Now, the thing with this one is that if you just take a look at the axis, it's the purple is the axis, right? So meaning that as just as I can choose point A or point B as the beginning of my R, right?
Mhm.
The same goes here. So I can choose point C as the beginning of my point from the axis. But here you can see that the point on the axis coincide with the point of the force. Can you see that or not?
So meaning you can choose. Sorry, so meaning you can choose the point. Sorry, the force acting about point C as well. I'm a bit confused.
Okay, so this the purple axis have 2 points, right? Let's say this point A to point C, right? That's the axis, right?
Uh-huh.
And of course, if you separate it, the force is acting at point C, right?
Uh-huh. Yes.
So I have two options for my R here, right? Meaning I take from A to C, I'll get RAC, right? So I can calculate using RAC for this R. Is that clear for that one?
Yes. That one's clear.
Or I can start from point C, so become LCC. From here to here. But of course, it's actually the same point. Hence, LCC is actually 0.
But how is it we can start from CC? Not sorry. How is it we can start? Yeah, how is it we can start from CC? Because the question only asks from
The question asks from
A to C and B to C, right?
okay. The phrase here, do you understand? Okay. Find the moment of force about line connecting A and C. That one you understand, right? Meaning that
Uh-huh.
um uh okay. Kita chat dulu nak ke tak? Because I have content ni. Because line A to C is the axis. That one you understand, right?
Oh, uh-huh. Yes.
The axis, okay. So so line, this is the axis, right? Oh, from A to C, right? And then it also gives another axis or moment of F about line BC, line connecting BC. So BC also another axis. So BC is another axis, right? So it says the force, which actually on point C, right? So what is the moment produced by this force about this axis and about this axis? Which one is larger? That's basically the question, right?
Oh, okay.
Do you understand the question first, or
Yes, I understand the question.
right? So for force about this axis AC, I have two options for R. One is this. One is this.
Oh, okay. Now I see it. All right.
Okay.
Okay.
So when the actual force coincide or go through the line itself, it doesn't. It will. That is from the computational perspective. If from logical perspective, if just like if you have a force about a point, right? So if
Uh-huh.
the force goes through the point, it doesn't rotate the point, right?
Yeah.
So similar with the axis, it will not rotate the axis because it
Oh,
goes
okay.
through the axis. So that's basically just the component where you can prove. Actually, you can try to use RAC and RBC, meaning that you, because logically from C, meaning you can see that the force goes through point C, which is where the axis is, so it's 0. But if you just want to prove, let me try using RAC for example. If you calculate, and it should give you 0 as well.
Oh, okay.
But in terms of the understanding here, I hope you understand, meaning that um, because this C and this C is the same point, so R is basically 0. Hence,
Oh, okay. I just never thought of using from point C to C. never
Come on.
yeah, because I never really understood the part that you could actually use from, because it's an axis, so you could use any point on it, so it should give you the same answer. So I
Mhm.
never really thought of using from the C point to C point. So I can see why now you say it's zero, sir.
All right. All right. Okay. So understood.
Oh yes, understood.
All right.
Okay. All right, thank you, sir.
Welcome.